talk about heat and heating up substances. So if you have, like, for example, a glass of water and you put a little Bunsen burner underneath it, so now you're putting heat into this water and the water warms up. The question is, how much energy does it take to warm up the water? So each substance has what we call a specific heat or specific energy, and this is the amount of energy required to raise a mass of material by 1 degree Celsius, or by 1 degree Celsius, or 1 degree Kelvin. Remember, the only difference between degrees and Kelvin is where we start counting from. And now, every substance is going to have its own heating. So water is going to take a different amount of energy to heat than, say, methanol, or say liquid aluminium or something like that, if we heat aluminium up. So specific energy is going to be, for water, it is going to be 4.186 joules, kilojoules per kg per Kelvin. So to raise 1 kilogram of water by 1 degree Celsius or 1 degree Kelvin will take 4,186 joules. Or it's 4.186 joules per gram per Kelvin, your choice. For ice, because ice has a different structure, it's going to be 2.108 kilojoules per kg per Kelvin. And for steam, again, now the molecules are loose and can float around, it's 1.996 kilojoules per kg per degree Kelvin. So how does this actually work? So say I want to, how much energy does it take? So I'm going to make a cup of coffee to heat. So I put on a 300 mils in my jug, I put 300 grams of water from, well, what's my starting temperature? So it's 15 degrees Celsius in the room, to, well, we want to bring it up to boiling point. We don't actually have to, 1 to 100 degrees C. So we're going to bring it from about 15 degrees, which is the water comes out of the tap, to there. How much energy does it take? So Q, which is going to be the heat energy, equals, well, the change in the energy is going to equal the mass measured in kgs, times C, which is going to be the specific heat, and that's going to be in kilojoules per kg per Kelvin, times the change in temperature. And this is a big one, change temp. And this can either be K or degrees C, either or. So this is going to be the heat, change in heat. So Q, for some reason we use heat. So sometimes we use capital Q, sometimes we use little q, depending whether it's an intensive or an extensive property. and that's way beyond the level I want to go to in this video. So heat Q is equal the change in heat, the amount of heat energy, and because that's heat energy, that's going to be measured in joules. It's going to equal the mass that we're heating up times the specific heat of the substance times the change in temperature. So in this case, I am heating up 300 grams. 300 grams is 0.3 kg of ice. The specific heat is up here, 4.186 joules, kilojoules, sorry, per kg per Kelvin. And the change in temperature, well, it's going to be 100 minus 15 degrees C. So it's going to change 85 degrees. And so to find this out, we stick this in our calculator and we go 0.3 times 4,186 times 85, because 100 minus 15 is 85, equals 106,700 joules, to 4 significant figures. So 106,700 joules to heat up 300 grams of water by 85 degrees Celsius. Cool.